Alrighty, so today we are going to learn about molar mass. So molar mass is very oftenly used in stoichiometry to make conversions between moles and particles and grams, and it is just this great number and this great concept, and it makes a lot of logical sense. So how do we begin by calculating molar mass? Now, that's a very interesting question. So when you look at the molar mass, it's important to know like what even is this. So here I have the periodic table, and let's say we take hydrogen as an example, right? So this number right here, you can't really see it that well, but it says 1.008. That number right there is mass. It is in grams per mole. So 6.022 times 10 to the power 23. This many H atoms weighs 1.008 grams. Now, this is an extremely helpful number when it comes to conversions, like I mentioned before. But before we even get into it, let's learn how to even calculate molar mass. So, molar mass, for example, let's say we have NaCl, sodium chloride. So to calculate sodium chloride, its molar mass, we first need to find sodium and chlorine on the periodic table. There it is. And we take the number, the really small number right there, sodium, and the really small number right there, chlorine, and we add them together. So the molar mass of sodium chloride would be 22.990 plus 35.453, which would give you 58.443 grams per mole. So the molar mass of sodium chloride is that. Now, what about the molar mass of just chlorine by itself? So when it's just chlorine by itself, the molar mass is already written in the number, like the really small number right here, which is 35.45. So this is essentially what molar mass is. It is the little number written right there. But what happens when you get more complex? For example, sodium chloride. We just have one of sodium and one of chlorine. But when you get more complex in terms of molecules, it pretty much follows the same exact method. So for example, we have right here Mg3PO4, 2, I don't know the actual name, but you get it. So we have 3 of magnesium. So when you're trying to compute the molar mass of this, we cannot forget parentheses, right? So where is magnesium? Magnesium is right here. So 3 times 24.31 plus. Now, PO4 is a polyatomic ion, and this is being multiplied by 2 as a whole because of the subscript right here. So we need to have parentheses in place in order to properly compute this. Next, we have phosphorus. So phosphorus is right here. It has, let's see, 30.97 plus 4 times oxygen. Oxygen is right here. It says 15.999, which is just 16. And then I multiply this by 2. Once again, this 2 came from the subscript right there. And this molar mass would equate to 262.87 grams per mole. Now this makes sense, right? It's straightforward and the concept of molar mass makes sense. But what if we have something called a hydrate? So for those that you don't know, hydrates are essentially compounds that have set number of oxygen compounds to it. So I'm writing an example right here. And this dot right here, just like in algebra, it means multiplication. So that makes complete straightforward sense, right? So if I were to calculate the molar mass for this one, it would be 2 times 22.99 plus 2 times sulfur, which is 32.07 plus 3 times 16, once again 16 is oxygen, plus big parentheses because this is now we are computing the the water portion of the molecule, just like we did with the polyatomic one up here, right? So we put hard brackets, and then we do hydrogen, and then oxygen, and you multiply that by 5. So at the end, the molar mass should equal to 248 grams per mole. Just like that. Now, before I get too ahead of myself, this notation right here, these units, grams per mole, uh, you could write it like this, G per mole, but sometimes, at least IB does not like fractions, so this is what you do. The -1 exponent essentially means per. Also, this is the units used for molar mass. Awesome. So now we know how to calculate molar mass. We can go on to doing conversions. So right here, I have a little chart that shows molar mass and how to do conversions. Now, M right here is molar mass. It is molar mass, which is in the unit of grams per mole. Alrighty, so when you are given the number of moles and you are trying to get to the number of grams of it, you simply multiply it by M. Whereas if you're trying to go from grams to number of moles, you simply divide by it. So this is pretty straightforward. So let's do an example. Let's say you have 0.50 grams of CuCl2, and you want to know the number of moles that you have. So we're trying to go from grams to number of moles. Now before we do that, we need to know our molar mass, which CuCl2, its molar mass is 134.45 grams per mole. How did I get this molar mass? I did the same process like we did up here. Okay, so we're trying to go from grams to moles, so we divide by M. So we go 0.50 divided by 134.45, and we should get 0.0074 moles of CuCl2. Once again, make sure how I answered the question. You cannot just leave the question out there. You need to answer the question and do what the question is asking you to do. Additionally, notice how I put stuff in the proper units. Units are extremely important in this case. Okay, next we want to go from moles to mass. So let's say we have 2.00 moles of H2. Now that's simple, right? So we have the number of moles, but we need to find M. So M would essentially be 2.00 because up here, hydrogen, it is the molar mass of hydrogen of 1 mole is 1.008, which is very close to 1, so I think it's safe to round it. So the molar mass is 2. So now when we're trying to go from moles to grams this way, we multiply by M. So it's just 2 times 2, which is 4. So we have 4.00 grams of H2. Once again, make sure you have the proper amount of sig figs, and I hope this video helped. Thank you.